Good afternoon to all. Am I audible? Guys, am I audible? Yes, yes. Okay. Yes, thank you for the response. Okay. So just hold on for a few more seconds. Let everyone join the session. Then we'll start. Okay. Okay. In the meanwhile, let me explain. See, listen. See, this is for a Capgemini specific training. Hope you all know that, right? Okay. So here we are going to solve a problem. It's like what will be the output? We are going to solve the problem with the options. Okay, you can have an options, but what you have to do is you should know how to do a manual execution. You have to manually execute the given program, and your task is to find the output for the given one, right? Okay, so for solving this kind of problem, first we should know the fundamentals of a concept, fundamentals of C and data structure and algorithm. Only then we can solve this kind of problem, right? So the first 2 days of the session is going to be brush up the fundamental concepts. So today I have planned to cover all these concepts. Okay, first one, look at the first one. The first one is going to be a control statements. I hope you all know what is control statement and looping. Okay, so and I hope you all comfortable in functions also. In case if you're having any doubt in function, you can ask. I'll explain. Right. So the next one is going to be the enumeration structure union. So first you should know a structure. You should know a structure and then pointer, and one more important, it's going to be a dynamic memory location. And one more important, it's going to be dynamic memory allocation. So you have to be you have to comfortably handle this structure, dynamic memory allocation and pointer. Only then we can handle data structure problems. So for handling a data structure problem, definitely we have to be strong in all these concepts: structure, dynamic memory allocation, pointer, and also a function, right? And then one more important concept is going to be a pointer arithmetic. And then next let's start a basic data structure. Okay, so basic data structure means we can start from an array, matrix. Arrays also comes under a data structure, right? So and then linked list, stack, queue, tree, graph, keep on going, right? Okay, so this is the agenda of today session. Here, okay, how many of you joined here? Okay, 138 people are joined here. Okay, okay, hold on for a few seconds. Everyone join the session. Okay, okay, guys, shall we start the session? Guys, shall we start the session? See, guys, first thing you should understand that we are in a remote place, so I need response. At any point of time, if you don't know the answer, means you can say, feel free to ask doubts and share your answer, right? Okay, hope you all get that. Okay, thank you. Okay, guys, let's start the session. Okay, super. I need a response, right? Okay, first let's solve one question. Okay, first let's start with the program. Okay, so listen. First here I'll show you the option later. Okay, we are going to work without option first. Okay, so I'll show you the code. So listen, this is what we given program. Your task is to find the output of this one. It might have an error or some valid output also. Okay, so now this is the first question. So I'll show you the option, but hereafter we are going to work without option. Okay, and then later I'll show you the option. Okay, so this is the given program. The options for this program is going to be they have given a 4 option. They have named it as ABCD, right? So just take a look of this problem. Okay, I'll give you one minute to solve this one. Just take a look of it, then let's discuss the answer for this one, right? Okay, so just take a look of it. Guys, I don't know about this, just listen this. Okay, listen the session. I don't know about recording. Okay, super. Vaishnavi answer for this one, compilation error. Super. Anything else, guys? Compilation error. Okay. Guys, you can post your answers. Once you have solved this one, you can start post your answer. Compilation error. Okay. See, while posting answer, I'm just off my screen. Okay. Now you can post your answer. Yes, compilation error. Inside else. Super. Someone has answered inside else. Super. Compilation error. Excellent. Super. Inside else. Okay. Super. Super. Inside else. Okay. So listen. The most of the answer I got is going to be inside else, right? Okay. Super. So let me run this code. Let's see the output. Okay. Run the code and let's see the output. Look at this. Inside else. Okay, so listen, but it looks like a compilation error. Okay, so but listen here, we have I have write a if, and after that immediately without using any open close, I have write one more if also. So while processing this, if and else is going to be a pair. If this one if x is equal to 0, okay, so if this condition becomes true means this printf will get execute. Likewise else, if this becomes false means this printf, this else part will get execute, right? Okay, so x is equal to 1. So x is equal to 1 means if this is true or false, x, initially we have set this x as 0, right? So initially I am going to check this condition. If the first, if x is equal to means we have already assigned this x with 0, so that means this clearly says that this condition becomes false. So if this condition becomes false means the pair of this if is going to be the last one, so that only we got the output as inside else, right? Okay, so let me explain this one with one more problem. Listen. Guys, let me explain it with one more problem. So int main, I have used the int main, so that only I am going to write a return, right? So I have declared one variable. I just gave the name of var. This one I am going to set it as 1. This one I am going to set it as 1, right? Okay, so listen, initially I am going to check var is equal to 1. I'm going to check whether this variable having var, right? So immediately I'm going to write one more if var is equal to 0. So if this condition becomes true, I'm going to print 0, right? I'm going to print r is equal to 0 or else 0, enough, right? And then I'm going to write one else var, in this else I'm going to print 1. I'm going to print 1. So now tell me what will be the output for this program. What will be the output for this one? Super one. See guys, I just purposefully off my screen. So while clearing a doubt, okay, I just off my screen. I have done this purposefully, right? Okay. While reading your doubts, I just off this one. Okay, so 1. Let me run it. Let's see the output. Yes, 1. Super. Excellent. Right? Okay. So now listen. In case if I write 0, okay, if this one is equal to 5, so now tell me what will be the output. Now, what will be the output for this code? What will be the output for this one? 1. Still 1. Yes. Okay, nothing will get print. Okay, so 0. So I have a mixed answer. Nothing will get print. 0, 1, super, no output. Okay. Okay, so let's see. Nothing will get print. Yes, super. So listen. This else is going to be the pair of this one actually. This else is going to be the pair of this one. So likewise, we have write this if, first if without else. So if this condition becomes false, definitely we don't have any option. We didn't write any else. In case if we have write a else means that will get executed. Okay. So initially, initially we have write one if. This if is there without else. Okay. So listen, in case if I write one more else here, if I write one more else, okay, so let me print 5. Let's print 5. Okay, so if you run this else part will get work. So if there is no else for the first if means nothing will get print. Super, excellent, right? So there is no error and we didn't get 1 or 0. The output for this one is going to be nothing will get print. Clear? Okay, super. Next. Now, initially, I'm going to set my value as 0. Initially, I'm going to set this variable as 0 means, now tell me what will be the output for this one. See, actually, here we are learning a concept, right? Okay, super. So now we can post your answer. So what will be the output for this one? Super. 1, 1, yes, 1. Okay. 5. Okay, only one people said 5, 0, 1. Super. Okay, see guys, feel free to post your doubts. Okay, we are here to learning, so don't bother. You can post your answer. Okay, super. 1. Most of the answer is going to be 1. Right? Okay, let me run it. Yes, super. Your answer was correct. Super. Okay. See, listen. I already told you that now this if becomes what? This if becomes true. So once this if becomes true means we are going to execute the next if. In case if it is false means we will directly go to here. Right? Okay. So now this becomes true and then we are going to execute this one. See, one more thing what you should understand here is, here we didn't use any braces. We didn't write a block. Okay, so we didn't write like if inside a if. I didn't place any open closes. Okay, but it still works perfectly, right? Okay, so listen, if var equal to 5, so if this becomes true means this printf will get executed, otherwise this else part will get executed. So that only we got 1 as output, right? Okay, so now I'm going to delete this one. Now I'm going to delete it. So now tell me what will be the output for this one? What will be the output for this code? Var equal to 0. Now tell me what will be the output for this one? Okay, just take a look of it. No output. Okay, super. 5, 5, no output. 5. Okay, yes, 5. Super. Okay, so let's see the output. Let me run the code. Yes, super. 5 is going to be the answer, right? Okay, so listen, I already told you that this becomes true. So once this becomes true, we are going to enter into this part. And if this condition becomes false means we are going to execute the else part. Else, inside a else, we have write a printf. That printf is going to print a 5, right? So that is what we have done here, right? Okay, so listen, and if I write 1, definitely if you write 1 means for this if we didn't have a else part, so that definitely we didn't get any output. See, this is where we need a concepts. We have to be strong in concepts also. Only then we can handle this kind of problem. Clear? Okay. Okay, guys, do you have any doubt in this one? Do you have any doubt in this one? Okay, let's solve second problem. Okay, so let me, yes. Okay, guys, just let's move to the next one. Okay, look at this question. Take a look at this. Look at this. Guys, while come to this session, please have pen and paper with you. Okay, so these kind of problem, what you have to do is you have to do a manual execution. You have to do manual execution. Only then you can crack this kind of problem, right? So this is very simple. Now, when you come to a pointer question, definitely we need a pen and paper while solving this kind of question. So take pen and paper. Okay, you people are start answering. Okay, hello world 4-1, hello world 1. Okay, hello world 4. So far I got hello world 4 and 1. Okay, okay guys, anything else? Hello world 4. Okay, 1. Superb. 1 hello world 4. One more answer is going to be hello world, and after that we'll get 4. Super. Next. Okay, anything else? Okay, 1. Okay. So now let's start. Okay. So first of all, let me command this, only then I can run this code, right? So look at the option. Your options are 2, 1, hello world 4. So definitely there is no possibility for getting a hello world 4. So let me remove it. Okay. So you might have a hello world 4 or 1. Okay. So now I'm going to run this execute. Let's see the output. So the output for this one is going to be what? 4. So the answer for this problem is going to be 1, right? So how did we get 1? How did we get 1? Okay. So listen, I already told you that use a pen and paper for solving this kind of paper, right? So listen, here we have used a variable called a, I, b. Okay, so first let me list out all the variables a, I, b. So the initial value of a is going to be what? Initial value of a is going to be 0. Yes. I is going to be 0. Okay. And then b, they didn't initial it, and they didn't even use this b. Okay. We don't need to bother about this. Right. Okay. So and for this for loop, here they have write one for loop. For that they have again assigned 0 to your I. Yes. Again this I will get initialized with 0. And we are going to execute this for loop until this I value is less than 5. Until this I value is going to be less than 5, right? So once you have, and first thing, I have set my I value, and after that I'm going to check whether this condition is, see, this for comes under entry check. Looping, see, there are 2 types of loopings are there, entry check and exit check. For and while comes under entry check. What do you mean by entry check? Before entering into a loop, you have to satisfy that condition. Only then you can enter into that loop, right? So exit checking means you can run that loop, and after that I'm going to check will I continue or not. Okay, if that condition satisfy means you can execute one more time, right? So that is the difference between entry and exit. I hope you all know that. Okay, so the for comes under an entry check. So entry check means first we need to check the condition. So that only I'm going to check I less than 5. The initial value of I is 0. So 0 less than 5, obviously this is going to be true. Okay, so and look at the next statement. Now we have entered into a for loop. Okay, the first line inside the for loop is going to be a plus plus. So this a value will get increment. Okay, increment as 1. Okay, now and after that I'm going to check if I equal to 3. Look at the I value. Is it true? Is it true? I is equal to 3. I having 0. So obviously this condition is going to be what? False. So if this condition becomes false means there is no guarantee of getting hello world. because if this condition becomes true, we can get hello world. So now this condition becomes false, right? Okay. So if this condition becomes false means we need to execute this printf, and then next, look at the next statement. Next statement is going to be break. So what is this break? This break will terminate the execution of an immediate loop. Terminate the execution of an immediate loop. Sometimes you might have a for inside for also. Okay, for inside for means this break will execute the immediate loop which is present, right? So listen, this break means this break is present in this loop, like this one for I. So the moment we have reached this break statement, this for will get terminated. So once you come out from this for loop, while printing a value, look at the last value of a. You're having 1. So that only will get our output as 1. Right? Okay. So this is called manual execution. We have to execute this code manually. Clear? Okay. Guys, is this clear? Guys, is this clear for you? Do you have any doubt in this? Yes. Okay. So we have solved 2 problems. So let's back to the concepts and then we'll solve a problem. Clear? Okay. So now back to the concepts. Listen. And now only we have discussed this control statement and loop. Hope you all know this. Okay. So let's back to the function. Okay. So how many of you having doubts in function? Guys, how many of you having doubts in function? Explain the condition for inside for. Okay, you want me to explain for inside for. Okay, super, I'll explain. Okay, first let's finish that. Okay. So I'm going to use the same thing. For inside for. Okay, so here I'm going to declare for ij. So for 5, this one I'm going to run for 3 times. Sorry. Okay, no problem. So inside this one I'm going to print. Let's print star. Just take this as simple. Okay, for I equal to 1, I less than or equal to 3, I plus this. Okay, for inside for. Okay, so listen, look at this code. Here we are going to run this for loop. Okay, so for make you the difference, this one I'm going to run for 5 times. Okay, so this one I'm going to run for I loop is going to run for 3 times. At the same time, J is going to run for 5 times. Clear? Okay. So now listen. Let me explain the execution of this one. See, people who already know this, just ignore this. Okay, I'm just explain this one for the people who are having doubt on this one. Clear? Okay, so I is equal to 0. So first execution, I initially started with 1. So I'm going to check whether this becomes true. Yes, 1 less than or equal to true. So this is true means I'm going to enter into a for. Okay, inside this for, again I have write one more for. For this for loop, we have used a j variable. Yes, I'm going to set this j from 1. Okay, so you are going to execute this until satisfy this condition, j less than or equal to 5. Okay, so now if this is true means you are going to enter into this for loop. Listen, enter into this one, execute this code. That's it. This code will get executed. We don't need to bother about this one. Okay, we are going to just focus only on the execution. right? So j starts with 1 true, and then next increment by 3, and then 4, and then 5. Yes, once your j value becomes 6, once your j value becomes 6, this condition becomes false. So this condition becomes false. So once this condition becomes false means we have completed this entire for loop. We have completed this entire for loop. And then your control goes over here. Your control goes over here. Now your I value will get increment by 2. I value will get increment by 1. So your I becomes 2. And then you're going back to this condition checking. Yes, 2 is less than or equal to 3 means this condition is true. So once this condition is true, again you are going to enter into a for loop. So again we are going to execute this j for loop one more time. So for that, again you should start your j from 1, and then 2, and then 3, and then 4, 5. So once your j becomes 6, this j condition becomes false. J loop will get terminated. Okay, after that your control goes over here. So once your this I value will get increment by 1, so that this becomes 3. For this 3, again we are going to execute this j loop. And for the next time, this I value will get increment by 1, so that your I becomes 4. While checking this condition, 4 is less than or equal to 3, automatically this becomes false. Clear? Okay, so this is how this for inside for works. Yes, super. Now let me explain this break. Okay, listen. If my I value equal to, I am going to break it. If my I value is equal to 2 means I am going to break it. Okay, so listen, I already told you that if you have write a break inside a for means, this is work only for the immediate loop. Immediate loop is nothing but this break is present in a j loop. This break is present in a j loop. Okay, so only this j loop will get terminated. Only this j loop will get terminated. Only this j loop will get terminated. Right, so how did we know that? For that I'm going to print some value. So what I'm going to do is I'm going to print a j. Once you have completed a I means I'm going to give a new line. That's it. Okay, this thing fills, and this place is not only for incrementing and decrementing. Whatever you want, you can write it here. See, while altering a I value, I would like to do this thing also means you can write that entire thing here. But what you have to do is you have to separate that statements by comma. That's it. Here, while writing a printf here, you don't need to specify, you don't need to give a semicolon, because semicolon always it's going to be a terminator operator. Once you have completed the line, or once you have completed this line means at the end you should specify it with the semicolon, so that only we just call this as a terminated character. Clear? Okay, so let me run it. Listen. Okay, actually this j loop should get increment. This j loop will get execute for 3 times, but we got only a 2. The reason is here I have write this break. Okay, so now if I execute this while running this code, you will get 3 times. Okay, so now here, once your I value becomes true, we are going to break only a j loop. But I would like to break I loop. I would like to break a I loop. So how will you handle that case? So for that case, what you have to do is once you come out from this j loop, this is going to be j. So once you have come out from this j loop, again I'm going to check if my I is equal to 2. Again I'm going to check my I is equal to 2. So if you have checked I is equal to 2, whether if your I having 2 means I'm going to break it. Now look at this, this will execute only once. So the reason is we have break both the for. So this is how for works. Okay, clear? Okay, explain Okay. Next doubts is going to be passing array to a function. Super. So for that we should know a pointer for passing array to a function. Yes, super. So let me explain it. Okay. Okay, before that, first of all, what's an array? Array comes to a explained nested if else. Okay. Let me note out your doubts. Okay. So passing array to function. Okay, next one is going to be nested if else. Okay, so first finish that passing array to function. Okay, so first of all, okay, what do you mean by an array? Guys, what do you mean by an array? Arrays also comes under a data structure. We are going to organize a data for a better usage, right? Okay, so what's an array? Hello guys, what is an array? Group of similar data types. Super excellent. Group of homogeneous data. Okay, super excellent. This is the correct term we supposed to use. Homogeneous data, collection of similar data types. Okay, super. See, yes, super, group of similar data types, collection of similar. Okay, super. Okay, and then one more thing, array index always starts from a 0. Array index always starts from 0. Array means this is going to be a contiguous memory allocation, right? Okay, collection of data having a similar. Okay, super. Collection of homogeneous elements of a same type. See, listen, Harshita. Okay, see, Harshita, collection of homogeneous elements of a same data types. Once it is homogeneous, once you have mentioned it as a homogeneous, means obviously data type is going to be same. You don't need to specify it. Okay, so once you have mentioned it as a homogeneous, means obviously the data type is going to be similar. We don't need to specify it. Yes, super. Array starts from 0. Okay, let me list out the points for array. Okay, here array. So the first one is going to be homogeneous data, collection of homogeneous data, similar data type. Okay, and then array index always starts from 0, and then this is going to be a continuous memory allocation, continue memory allocation or continuous memory allocation. Nice, continuous memory allocation. And one more thing, so listen, here it can be either a static type array or dynamic type array. Static array means once you have declared it as an array, we can't change the size of that one. I will explain it. Okay, so it can be either a static memory allocation or dynamic memory allocation. Address is going to be continuous. That's it. This is array means it's having a continuous memory allocation. It can be either static or dynamic. Okay, so in case if it is a static, means size is going to be fixed. Size is going to be fixed only for a static memory allocation. If you have declared this as a dynamic memory allocation, means you can change your size. There is an option, right? Okay, and continuous memory allocation, homogeneous data type, array index always starts from 0. Okay, anything else? Guys, anything else? Pointer always assigned to a starting address of array. See, we can't say like that. I'll explain it. Okay, see, how can we say is array name, it always points the starting address. Pointer always assigned to a starting address of that array. We can't say like that. Okay, so the correct statement is going to be array name itself always points the first element address, starting address, or we can say this is the first element address. So array name itself, so array name itself points the first element points the address of first element of an array. Right. So array name itself points the address of the first elements of that array. So this word itself says that pointing. That means definitely we need a pointer. Definitely we need a pointer. So in case, but there is a difference while it be in a static or dynamic. There is a difference. Okay, that I will explain it. Okay, guys, anything else? Guys, any other points that we have left here? Guys, anything else? Guys, see, guys, at any point of time, if you don't know the answer or if you don't have any idea, so what you can do is you can post a dot. Okay, so if you don't have any idea or if you don't know the answer, super. So instead of saying a no or like that, better is to post a dot. Is any other points? Do you have any other points for array? Yes, super. Yes, okay. So let's start. We don't need to waste our time. Okay. So first, let me command all these things. Okay. First, let me finish what is a static array and dynamic array. Okay. First, let me finish that one. Is it int array of n? So here I have declared one array with a size of 10. So now tell me, is this a static or dynamic? Is this the static? See, I'm just talking about a memory allocation. I'm just talking about a memory allocation. Is this a static memory allocation or a dynamic memory allocation? Guys, is this a static or dynamic? Don't know. Super. So listen. Yes. Okay. So this super excellent. Okay. So static, super excellent. Static. Start is going to be the correct answer. Listen. Static memory allocation means once you have declared, hereafter you can't resize your array. Hereafter you can't resize your array. Right. So once you have declared, while declaring it, let me take it as 5. Let me take this as 5. Okay. So here I'm going to declare array with the size of 5. Okay, so listen, inside this array, if you want, you can store a element 30, 40, 50. This is going to be my array element. As we know that array index always starts from where? Array index always starts from 0. Okay, so this is going to be the index of your array, and this is nothing but the element that we have stored in it. Right, so the name of this array is going to be or. The number of elements, that is on other hand, you can say this is, yes, number of elements of this array is going to be 5. So here we have 5 elements. The index is always started from 0, so that you should end up with 4. You should end up with 4. right? So and I just add one more point. This is going to be a contiguous memory allocation, right? So if this is starts from 2000, so the starting address of this array is 2000 means the next location is going to be what? The initial element, the first array element which is stored in a 2000. See, this 2000 is going to be a referral address. It can be anything, right? So for example, I just took this 2000, right? Okay. So the initial location is 2000 means next location is going to be what? Next location is going to be what? Okay, 2002, 2001, 2004. Yes. Okay, so listen, the correct answer is going to be 2004. The correct answer is going to be what? 2004. Yes. 2002 is also correct. If you are using a, okay, super, 2000 plus size of that data type, this is the excellent, super. See, this size of integer is changing based on the compiler. If you are using a Turbo C, you will get 2002. If you are using a GCC, you will get 2004. Okay, so now we are using a GCC only. For your interview process, they are going to use only a GCC compiler. So stick on to a 4 bytes of data. So integer occupies 4 bytes. So always listen, 2000 is going to be the first size. Okay, when finding the next location, you should focus on the data is pointed by this address, right? So this 2000 is pointing at 10. 10 is an integer, so it's going to occupy a 4 bytes of memory, means the next addressing is going to be 2004. So on other hand, 2000 plus 1, definitely you will get 2004. 2000 plus 1, what will you get? This plus 1, so listen, here you'll have a difference. This 2000, it can be an address or a data. It can be either address or a data, right? So it can be either address or data. This is nothing but a pointer arithmetic. So this is called a pointer arithmetic. Okay, so that I'll explain it later. So 2004, and the next one is going to be 2008, and then 2012, and then this is going to be 2016. So look at this, address or in a continuous order. So that only we have said this is going to be a continuous memory allocation. See, after that only here you will get 2020. You will get 2020. So likewise here also will have some address. So in C program, okay, C doesn't have a boundary checking. C doesn't have a boundary checking. Okay, if you try to access the fifth index of this array, okay, so the size of this array is 5 means you have to access only up to 4. If you try to access 5, okay, this won't give you an error. This won't give you an error, right? So the reason is C doesn't have a boundary check. In case if it is a C++, Java, Python, okay, so they will throw you an error, exception handling, because C doesn't have an exception handling concept. Clear? So we have to be careful while handling this array. While handling this array, you have to check your boundary. Clear? Okay. So now listen, this is going to be the starting address of this array. So I already told you that array name itself, it points the starting address. Here this is going to be an array. I'm going to initialize my array 20, 30, 40. If you didn't initialize, means the default value of this array is going to be a garbage value, right? Okay, so here I'm going to first let me print the array name, print of array. So this will gives you the starting element address. Okay, how did we know that this is going to be the starting element address? For that, what we can do is we can apply a value add. Okay, so this is nothing but one of the operator. Okay, so value add, we can call this as a value add. You can use this near the pointer. So this array gives us an address, so that after that I have used the star for taking a value from that address. So value at address. So you can read this as value at starting address. Starting address is nothing but it's going to be a tens address, right? So if you run it, you will get 10. So this is going to be the starting address. We can conclude this is going to be the starting address, right? Now I'll do that. This is going to be a continuous address. Array plus 1. Okay, array plus 1, what will you get? See, for some reference, we have taken a 2000, but this is going to be the actual address. Don't bother about the address. Look at the difference between these two. The difference between these two is going to be what? Difference between these two is going to be 4. Because this is going to be an integer type array. In case if it is a character type array, means the difference between these two addresses is going to be 1. If it is a float, means 4. If it is a long int, means it's going to be 8. So based on the data type, this difference will get changed. Clear? Okay. So now next one, array plus 2. Sorry. Look at this. Address is going to be a continuous. If you want to print the all address, means instead of write your printf like this, what we can do is index starts from 0, index less than 5, because the number of elements in this array is going to be 5. Inside this printf %d, I am going to print array plus index. Listen, initially I am going to add 0 to the starting address, and then 1, and then 2, and then 3. Right? Okay. So we need to declare this index. Yes, let me run it. Look at this. Address are in a continuous one. So this is how this addressing works in an array. And array name itself, it gives you what? Name itself, it points the first element of this array. Okay, if you want to get the address of the next element, means what you can do is you can add 1 to that starting address. Definitely this will take you to the next element address, right? So if you have add 2, let's take 2000 plus 2. If you add 2 to this address, this will gives you what? 2000 plus 2. What will you get? Yes, what will you get? Super, excellent. 2008 is going to be the correct answer. Right. So if you add, so if you add 2 to the starting address, means definitely this will take you to the place of 2008. This is how, see, for understanding an array, we should know how to handle a pointer also. Right? Okay. So this is how this addressing system works. Right. Okay. And next thing. Okay. So if you want to print an element, means what you can do is array plus index. This will gives you the address of an element. But if you want to take an element from that address, what you can do is you can use a value at operator. Okay, you have to use a value at operator only in the place of an address. Value at address. So now let me run this. Listen. If you have used a value at operator, you will get the value instead of getting an address. Clear? Okay. So generally we have accessed our array element like this, array of index. So this is one way of accessing your element. And another way of accessing your array elements is going to be array plus index. If we have write array plus index, as we know that array is a name of an array, so definitely this will gives you an address. Address plus integer. Okay, so this is nothing but address plus an integer. Index is always is going to be the type of an integer. So address plus integer, you always end up with only an address. So array plus index, what will you get is you will get the address of some location. That's it. So if you want the data from that address, you can use a value at operator. Okay, so what you can do is array plus index, you can use a value at operator. So this is another way of accessing your array elements. So these two statements clearly shows that array and pointer are interconnected. Array and pointer are interconnected. We can view array as a pointer and pointer as an array. Clear? Okay, so this is the another way of accessing your array elements. Clear? Okay, guys, do you have any doubt up to this? Yes, super. A of 2, which is similar, is equal to a plus 2 value at. Yes, super, excellent. Guys, do you have any doubt up to this? So now we have finished this array. Then let's move to a pointer. And then let me explain how to pass an array to a function. Right? Yes. Okay. So now next one is going to be a 100. Let me explain a pointer. In number, I have declared one variable. Okay, so after that I'm going to set this as number. Okay, once we have declared a variable, what happens is going to be here. This is our location. We have named this as number. Okay, let's take this is in a 3000. Inside that I have stored 10. I have stored 10. Right. So this is going to be the value. Okay, so this number is nothing but the name of this memory location. Memory location is going to be 3000. Name of this memory location is nothing but num. Right. So number, if we have access this variable name, you will get 10. You will get 10. Right. So now tell me, how will you take the address of this one? Address of, for that we can use this operator address of. Address of number will gives you a 3000. Address of number will gives you a 3000. Right. So now can I write like this? Can I write like this? No, you can't write like this. The reason is number itself, it gives you a 10. But for this value at operator, okay, see, this will work only for an address. Number will having a data. Number will gives you what? 10. So you can't use this value at operator for a data. So that what you can do is address of number. You can write like this. So for solving this one, you should start from here. You should start from here. So this number will gives you what? 10. This number will gives you 10. Now address of number will gives you 3000. Value at 3000 is going to be 10. Value at 3000 is going to be 10. So this is what a pointer. Right. So for handling a pointer, what you have to do is what you should know. Okay. So for handling a pointer, you have to be comfortable in this address of and value at operator. For taking an address of some data, you can use address of operator. If you want to take a value from particular memory location, for that you can use a value at operator. Right. Okay. So now after that, what I'm going to now is I'm going to declare one pointer. I'm going to declare one pointer. Right. Okay. So now before that, print of %d number, address of number. Okay. I'll just show you the address. So this is nothing but the address of a 10. Am I right or wrong? This is nothing but the address of a 10. Okay. So this is going to be the address. Just take a look of it. Okay, let me copy it. Let me copy this address. Okay. So if you add 1 to this one, what will you get? If you add 1 to this one, what will you get? What will you get? You will get 6, 3, 5, 6, 7, 3, 6. Am I right? If you add 1 to this one, if you add 1 to this one, what will you get is you will get 6, 3, 5, 6, 7, 3, 6. Right? Okay. So listen, let me explain it with some okay. Int ptr. This is a pointer. No. See, this is a variable. I just name it with ptr. That's it. I just name it with ptr. But this is nothing but a variable. So ptr is equal to 2000. I have assigned this into a 2000. And after that, what I'm going to do now is I'm going to add 1 to this one. So now tell me, what will you get? Now tell me, what will you get? Guys, now tell me, what will you get? What will be the output for this one? See, I have declared one variable. Inside that one, I just store a 2000. After that, I'm going to add 1 to this 2000. While adding, I'm going to print this result. So what will be the output for this one? 2001. Super, super, excellent 2001. But someone said 2002. 2001, super, excellent, 2001. You will get 2001. This is not a pointer. I gave a clue. Pointer is a name of that variable. You can give any name. If you want, you can give your name also to a variable. Name doesn't matter here. That's also a matter while doing a program. You should give a proper name. Right, so if this is a variable means this is just a variable, but I just name it as a ptr. Right? Okay. So listen, if you have mentioned it with star, in case if it is an address also means if you have assigned it to some variable, okay, this is considered as a number. This is considered as a number. Now listen, now I just mentioned this as a pointer with help of one symbol called star. So we are going to mention it as a pointer with the help of that star symbol. Okay, so let me run it. Listen, now what you got? You got 4. So listen, for a compiler, see, for us, we can easily understand whether it is a data or a pointer. But for a system, but for a processor, we have to differentiate whether this is a pointer or a data. So that only we need the star symbol for mentioning. While declaring a variable, you have to mention this is a pointer. Naming doesn't matter. You need to mention this star symbol while declaring. Right? Okay. So listen, and let me show you one more demo. Number is equal to 10. Instead of now, listen, I just declare this as a ptr. Inside this, address of num. So after that, I'm going to print a ptr and then address of num, both. I'm going to print both ptr and address of num. Both should gives you the same value because address of num we have stored in the variable called ptr. So that means both should be equal. Let me run it. Yes, it works perfectly. It works perfectly. So listen, here there is no error because your address is always going to be in the type of an integer. Address type is going to be integer. Right? Address type is going to be what? Integer. If you want, you can store your address in the variable called ptr. After that, you can use it. So now tell me, this ptr is just a variable. This ptr is just a variable. Right? So this one has stored the address of a number. While printing, what you got? You got the same value. But listen, if you try to add 1 to it, what I'm going to do now is I'm going to add 1 to this one. While doing an addition, there is a difference. Look at this, while doing addition, there is a difference. The reason is this PTR is just a variable. This is just a variable. Variable means system is going to consider this as a number even though it's an address. Even though it's an address, for system, you have mentioned it as a variable. So system is going to consider this as a variable. So that only while performing addition, you will get one difference here. But address of num always is going to be address. So if you add 1 to it, you will get the difference as 4. Right? Okay. So in the same example, if I put star over here, now both work the same. Look at this. Now both works the same because now this value is treated as an address because we have mentioned it as a pointer. Clear? Okay. Guys, is it clear for you? Guys. Yes. Okay. So this is the pointer. Yes. Super. So this is how we can use the pointer. So this symbol is important while declaring a variable, right? Okay. Okay, and the next thing is going to be, and hope we all know that basic of a function. Now here, what I'm going to do now is, I'm going to write one function for printing an array, for a function for printing an array, right? Okay, listen. Okay, so listen. Printf %d size of array. What will you get? Here I have write a code for printing. Let me comment it. So now tell me what will be the size of this array? What will be the size of this array? Can you explain about changed pattern? Changed pattern once. Okay, super. I'll explain. Sweta, wait. I'll explain. 20. Super. The size of this array is going to be what? 20. Size of this array is going to be 20. So if you run it, you will get 20. Right. And int star PTR. Here I have declared one pointer. That pointer I'm going to assign it with R. That pointer I'm going to assign it with R. And as we know that array name itself, it points the first element address. Right? So array gives you the address of a starting one. So now if I print size of PTR, okay, so if you have write the size of PTR, what will you get? What will you get, guys? So now tell me size of PTR will gives you what? Okay, Manoj Kumar, 5 into size of data type. Super, excellent. 4. Super. What will you get? You will get 4. Super, guys. You will get exactly 4 because this is a pointer. Right? So this is the reason while passing an array, you should pass your size along with that array. Because listen, so now here we are going to call one function called print array. For that you should pass an array. Okay, so while passing an array, what we have to do is you should pass the number of elements of this array. This number of elements we can get it from a user. Okay, listen. If you want to get this input from a user means what we can do is See, n is equal to n also you can get it from a user. Okay, first thing I'm going to get from a user is going to be a number of elements. Okay, number of elements, and after that I'm going to declare an array with the size of this n. After that I'm going to declare this array with the size of this n. But once you have fixed this array size with n, means hereafter you can't change it. This is going to be a fixed one, because this what we have done is here we have done a static array, static memory allocation. Right, and after that I'm going to read an input from user. For that, index less than n index plus plus. Now we are going to work to based on the number of elements given by the user. So inside this, scanf percentage the address of array of index. Address of array of index, because generally array of index will give you one value. But for scanf, we should pass an address. So this is one option, or else what you can do is we can directly take array plus index. Okay, so array name itself, it gives you one starting address, and then you can add index to it. If you add index to it, definitely you will get an address. You don't need to write address of array of index. Right, and after that I'm going to call this function print array address of n. Right, so listen, for writing a function, always better is to start from a function calling part. This is going to be a calling. First finish a calling. So once you have finished a calling, just copy the same thing and paste it here. Now what we are going to do now is, now we are going to declare a function. See, we can't use any variable without a declaration. Likewise, while using a function also we need to declare it. Right, so in case if there is any return type is there for this function, means you should specify that. Otherwise, make this as void, because the default return type of the function is going to be an integer. Right, so now here you should place a semicolon, because this is a declaration part, or we can call this as a prototype of a function. Right, okay, so listen, now array. This is the actual parameter. This is going to be the actual input. For a calling phase itself, we have passed the actual input. But at the declaration part, at the definition part, we didn't know the actual thing. So we are going to use a formal parameter instead of using an actual one. So here array. As we know that array name itself, it gives you some address. It gives you some address. So definitely this is going to be a pointer. So that way I have used that star operator. And look at the type of your array. Your array type is going to be an integer, means definitely this is going to be an integer pointer. That's it. And then next one is going to be n. You have passed the n. N is in the type of an integer, so that instead of this n, you can use an integer. Okay, so listen, why did we have passed the size, passed the number of elements along with its array, means while passing an array, okay, we have passed an address. Right? So inside this print array function, y print array, for this one, first parameter is going to be an array, second one is going to be an n. See, you don't need to give the same name, you can give any name, but I just kept this as the same name. Right, there is no rule for that. Right, so here inside this one, if you have calculated a size of array, definitely you will get only the 4 bytes alone. Definitely you will get only the 4 bytes alone. The reason is we have received this as a pointer, but by nature this is an static. By nature this is an static, but while passing to a function, we have passed this as an address. No other option. Array name itself always going to be an address. So there is no other option. While passing an array, it always goes in the type of an pointer. So that only we can't calculate a size inside this function. So that only while passing an array, better is to pass your n. Right, and we know that we can see our array as a pointer as an array, so that we have received with the pointer, but this is an array, right? So you don't need to bother about. You can access your array as normal. So while printing, we need to get an array elements. So array of index. That's it. So while accessing, you can access like this only. You don't need to bother about this part. Right? So it can be a pointer. This is one option. Or else what you can do is you can declare like this also. This is one option. You can declare like this. Just leave that size place as empty. This is one option. Okay. So I'd like to explain that pointer so that only I just mentioned it as stop. This is one option, or else you can leave as it is. And that case also it's going to act like a pointer. So the system is going to handle this as a pointer. Right? Okay, and this is a call by reference for that array. This is going to be the call by reference for that array. Right, so what is call by reference? Call by reference is nothing but we are going to take the original. We are going to carry the address of the original data instead of carrying a copy of data. So listen, after done a printing process, here I'm going to change my first element of an array. Okay, so after calling this part, if you print the first element of this array, that got changed. The reason is we have passed this. Okay, I didn't declare an index. Let me declare it. Okay, listen, 5, 10, 20, 30, 40, 50. This is going to be my array elements. Listen. So this printf, this is our scanning part. Okay, so after that print array has done this job, and then listen, still our array is having 10y. Sorry, array of 0, right? We supposed to change array of 0, but I changed this array of index. So listen, 5, 10, 20, 30, 40, 50. Look at this. So our array, original array got changed. The reason is we have passed this as a reference. So this is called by reference. Clear? Okay. Guys, is it clear for you? Passing function to an array. They have any doubt in this? There's any doubt? Clear? Okay. Guys, shall we take a 5 minutes break? 5 minutes or 7 minutes? Shall we take a break? What is this? One second. Get 10 minutes break. Okay. But you should come back shortly after 10 minutes. Okay. You should not take more than 10 minutes. Oh, 15 minutes. Oh my God. 15 minutes. It's too much. Okay. 7 minutes. It's okay. You're asking at 10 minutes. So I'll give you 10 minutes. Don't take break more than 10 minutes. Okay. Now the time is going to be 3:21. I'll start in 3:31. Okay, or 3:32. Okay. Okay, guys, you can take a break. Star history, you asked me to display the program. Yes, I'll show you the code. I'll display it. Okay, guys, you can take a break. We'll start the session at 3:32. Okay. Okay, this time a bit slow. Okay, so I'll explain it once. Okay, so listen, first we are going to declare one variable to read number of elements, right? So first scanf plus of n, and after that I'm going to declare an array according to this n, right? So now after that we can scan the array of elements. So array index always starts from 0, as we know that index less than n, index plus plus. Inside that one I'm going to write a scanf. So scanf, we should always pass the address of an element, right? So array of index always gives you an element, but we need an address means, so that only here I have used address of operator. This is one option to read a data for an array, right? On the other hand, what we can do is we can use that pointer arithmetic concept also, array plus index. So array plus index will give you one address. So if you have used a pointer arithmetic concept, you don't need to place the address of symbol, because this one will give you as an address, right? So after scanning this, what I'm going to do is I'm going to call one function called print array. This is the function we are going to use to print our array. So name itself says that printing array. So definitely we should pass array. While passing an array, you should pass number of elements along with its array. I already told you the reason. Why did you pass this n along with its an array? Because listen, inside this array, sorry, inside this main function, look at the nature of this array. This is in the type of a static array. So if you print the size of this array, this one will gives you what? Print of percentage d comma size of array. So this one will gives you the size number of bytes that we have taken for this array, right? Okay, so I forgot to declare an integer. Okay, let me declare it. So five elements means you can give a 5 numbers. See, it may not to be an increasing order, it can be anything, right? So 5 means totally we have allocated 20 bytes memory for this array, right? So this is in the form of an array, so that only while calculating a size, we got 20 bytes. Size of always gives you the result in terms of a bytes, right? So if you have assigned this into a pointer, here I have declared one more variable called ptr. Okay, so I just name it as ptr. This is a pointer. We can call this as a pointer because while declaring we have used this star operator. So after that, I'm going to assign this array to a ptr. Okay, so array name itself, it points the first element of this array. So that address we have stored it in the variable called ptr. After that, if you have print a ptr, listen, this array we have stored in some variable called ptr, but we have copied only the first element address alone. So while calculating a size, you got only the, see now first, now this one will gives you what? 4 bytes, because size of the address is going to be 4 bytes. That is the reason while passing an array, you should pass the number of elements also. While passing an array, you should pass number of elements also. Because inside that function, we can't calculate a size. If we have calculate a size, that will gives you only the size of your address, but we need the entire array size. So that only we have passed it. That is the reason we have passed it, right? Okay. So now let's back to that function. Print array is our function name. Print array is our function name. Array n. So this is our calling phase. This is our calling phase. So once you have finished the calling, what you have to do is we are going to declare this array. For a declaration, what I'm going to do is I'm going to copy this entire thing and paste it here. Copy this and paste it, right? So here we don't need to return anything, so that I'm going to mention it as void, because the default return type of this function is going to be an integer, but we don't want to return anything, so that only I just mention it as void. And listen, while calling, actually while calling a function, we need to give an actual input to that function, so that only we can call this as a actual parameter. We can call this as a actual parameters, right? So in a declaration part, we are going to mention only a formal parameter. This is going to be a formal one. So listen, here you have passed what array. Array name itself, it gives you what address. So that only here I am going to use the address of pointer. And look at the type of your array. Your type of array is an integer. So that here I am going to use integer array. And then next parameter I have passed to this function is going to be an n. N is also in the type of what? Integer. So instead of this n, now I'm going to add this n. That's it. Here. Okay. So now we have done the declaration. Now let's move to the definition. While doing a definition, what you can do is you can copy the entire thing and paste it here. Okay. And then open, close. This is going to be, you can receive it in the different name also. You can receive it in the same name or different name. Anything, anyway, this is both are going to be a different one. If you are using a same name or a different name, they are going to be a different, right? And the next one is going to be, I'm going to receive it in the name of number of elements. Okay, the second parameter is going to be number of elements. See, the purpose of writing this function is going to be just display all elements of an array. So that here I'm going to write an index. I'm going to declare one variable called index. So for index starts from 0, index less than number of elements. We are going to execute this index which is less than number of elements, because 5 elements are there, means we need to access only the access up to the 4th index, right? So index plus plus. So inside this one, what I'm going to do is I'm going to do a printing process. So percentage d space, and after that what you have to do is next. Here we have received in the name of our array is going to be ptr. So instead of using an array, you have to use a ptr of index. You can access like this. You don't need to bother about this is a pointer. Okay, so we know that we can view our pointer as array as pointer. So you don't need to bother about this is a pointer. You can access like a normal array. This is how we have accessed our array elements. So you can access like this. Okay, so I'll show you the code once again. See, this is the entire code. Just take a look of it. In case if you're having any doubt, you can ask your doubt. Okay, just take a look of it. I'll just show you the code. Okay, so this is the entire code of this program. So this is declaration and then calling, and here this is going to be a definition part. This is nothing but the definition, right? Okay, so take a look of it. Guys, any doubts? Guys, any doubt on this? See guys, I'm just explaining for the people who are having doubt on this. Okay, people who knew this already, just take a break. Okay, we finish this. Yes. So now let's run this. 6 elements. See, I already told you that you can give any number. So totally I have given 6 number. Listen. So this print array function print all elements of our array. Right. So here I just had one more additional point, which is this is going to be the call by reference. Okay. So listen, why did we call this as reference? Means while passing an array name it always gives you an address. So while passing an array, this is carrying an address. So this is going to be what? This is going to be the call by reference. So the proof for that one is going to be inside this print array function. I'm going to change the first array element as 1000. So for proving that, I made some changes inside this print array. Let's check, will it reflect on the main function? Okay, let's check, will it reflect on the main function? After call this function, I'm going to print that first element. So I'm going to print that first element inside a main function. In case if this is a call by reference, means this should get reflect on your main. That means your original should get changed. Your original should get changed. If this is a call by value, that means call by values means we carried this copy of a data. At that time, you just change your copy alone. Your original still remains same. If it is a call by reference, means your original should get reflect. That is what I'm going to check here, right? So now let's sorry, here we just we're supposed to use the name called PTR instead of an array, right? So let's take 6 elements. 1, 2, 3, 4, 5, 6. This is what are 6 elements. So after this one, listen, I have a printer array of 0. That array of 0 got changed because this is a call by reference. So that one way I just said this is a call by reference. Okay. Guys, is it clear now? Guys, any doubts in this? Jai Krishna. Is it clear for you? Okay. So now we have done for a static memory allocation. Now we have done for a static memory allocation. So now let me finish that dynamic memory allocation also. Static memory allocation means once you have declared this array with the size and means hereafter you can't change that one, right? But if you declare this as a dynamic means you can change it. So now let me explain how to do a dynamic memory allocation. That is very similar to this one. So what I'm going to do now is I'm going to copy the same code. I'm going to change only the gonna change only the memory allocation part alone itself. So copy the entire thing and paste it here. Okay, so listen, I'm gonna change only this part. Actually speaking, this line also will get changed. That's it. Okay, so as we know that for doing a dynamic memory allocation, we can use MLOC or CLOC. We can use MLOC or CLOC. If you did a memory allocation with the help of our MLOC and CLOC, in future you can do a reallocation. You can do a reallocation. Okay, you can do reallocation only for the memory you bought with the help of MLOC or CLOC. Okay, see. How the function takes value from main. See, from a main we have passed a value, right? Look at this. We have passed a value. See, here we have write a value. So that from here itself it takes a 1. And see, I think how it passing is while passing these elements, all these elements, or they are going to place it on a stack. I don't want to go in that much deep on that problem. Just pass, that's it. Okay, see, go with the flow. While calling, we have passed a value. This value is going to pass through that function. That's it. Okay. So if you want to discuss this thing, means we should know a microprocessor. I need to explain microprocessor also. So that only I just skip it. Okay. Manoj Kumar, got it? Okay. So now tell me, what is MLOC? What is MLOC? Okay. Okay. Thank you. What is MLOC? Guys, what is MLOC? Give me the prototype of MLOC. MLOC is also one of the inbuilt function, right? So give me the prototype. So you should know the prototype of an inbuilt function. Only then we can make use of that inbuilt function in our program. So right. So while learning an inbuilt function, so what you have to do is we have to learn the prototype, and along with that header file also. Only then we can use that inbuilt function in our coding. MLOC of size of. Okay. I think one bunch of people still taking break. 161 people are listening this session. What about others? Super. Typecasting MLOC size up. Super, excellent. So let me explain it. Okay. MLOC is the name of a function. malloc is the name of the function. Generally, we are going to use this memory allocation function for allocating a memory. So we are going to request the memory to a processor with the help of this malloc. Okay. So at the end, what happened is system is going to allocate some memory. Finally, they are going to return the starting address of that allocated block. Okay. So finally, they are going to return the address of that allocated memory. So definitely address means what we need, pointer. So the return type of this function is going to be what? Pointer. Okay. So far we didn't decide the type of that pointer. So that one day I just put star alone here. So for that malloc, what you have to pass? You should mention the size of elements. On other hand, what you can mention is number of bytes do we need. Number of bytes do we need. So if you want to store an integer data means definitely how many bytes do we need to store an integer? We need 4 bytes. Am I right? Yes. While doing a memory allocation. Listen, the scenario is while doing allocation, I'm going to request 4 bytes of memory. I'm going to request 4 bytes of memory. Okay, so this 4 bytes I can use it for an integer or a character. That is up to the user. Right? So we are going to just call this function for a memory allocation. Okay, compiler job is going to be just allocate a 4 bytes of memory. It's enough. After that, you can use it for an integer or character or a float. That is up to you. So that they are going to keep this as void pointer. What is void pointer? What is the advantage of void pointer? Void pointer is nothing but a generic pointer. Void pointer is nothing but a generic pointer. With the help of void pointer, you can store any type of pointer. That means once you declare that pointer as a void, with the help of that one, you can store an integer pointer, character pointer, structure pointer, file pointer, union pointer, whatever you want, you can store with the help of void pointer. So that is why we can call this as a generic pointer. This is the advantage of a void pointer. So, but before using, they won't allow you to use that address. If you want, you can just store it. But before using, what you have to do is you have to do a typecasting. Before accessing, the correct term is accessing. Before accessing that element from that location, what you have to do is you have to do a typecasting. Right? Okay. So first, let me explain it with some integer variable. Right? Int num. Generally, this is how we just declare one integer number. So this is a static memory allocation. So now what I'm going to do now is I'm going to do a dynamic memory allocation for this number. So for that, malloc, I'd like to store only one integer. So that size of integer. You can give a size of integer or else you can directly specify 4. Anything is fine. Right? So malloc, for this function, I have requested for a 4 bytes of memory. So as we know that this will return a void star. Okay, if it returns a void star means I can't store any data into that address. So that what you have to do is listen, void star. The star, you should not change this star. That means you should not touch this one because the star indicates return is going to be an address. But instead of this void, you can write a int. You can write a int. Why did I write a int means here I just bought a memory for an integer. I just request the memory for an integer means the typecasting should be done for an integer. Right? So now look at this. This malloc has written some address in the type of one void star. But now I had typecast this as an integer. So that means if you want to store this address in some variable means that should be the type of this typecasted address, typecasted type. We have just typecast this as an int star. So that means this PTR type should be int star. That's it. The star, you can place it anywhere. Okay, so while reading, how will you read it? PTR is a pointer. The star says that this PTR is a pointer, which is the type of an integer. That means with the help of this pointer, you can store a integer data. This is what it means. Right? So with the help of this pointer, you can store a integer. Clear? Okay. See guys, do you have any doubt up to this? In case if you're having any doubt, allocation at runtime or something else for malloc. Yes, we are going to do a runtime allocation. Yes. Guys, any doubt up to this? Do you have any doubt? Do you have any doubt in this? Please clear your doubts then and there. What if memory allocation it's not successful? Memory allocation it's not successful means you will get a null pointer. That's it. You will get the return as null. Yes, okay. So now this is how we can use a malloc. Here I just bought a memory for storing a one integer alone. Okay, if you want to use the same thing, if you want to do the same thing for an array means, as we know that array means collection of elements. So you should buy a memory for a number of elements. That's it. Right? Okay. So now we can as it is. Let me command it. Okay, listen. Here, in a previous problem, what we have done is here I just declare this as an array of n. Now, instead of this thing, what I'm going to do now is I'm going to use a malloc. Malloc of see totally how many bytes do we need? N elements. If your n is 5 means we need 20 bytes to store a 5 integer value. Right? So what we can done is n into size of int. And then as we know that we bought a memory for an integer. So while doing a typecast, we have to typecast this as an integer. And I'm going to store it in the variable called array. This array could be the type of what? Insta. That's it. Insta array. That's it. This 2-line alone, we are going to change it. That's it. Okay, we are going to change this 2-line alone. Everything is going to be same other than this. Right, so this is going to be a dynamic memory allocation. So 6 means 1, 2, 3, 4, 5, 6 will get changed. Everything is same. The difference is going to be only the memory allocation. Okay, so now but the advantage of this doing dynamic memory allocation is, see, initially I just said the size of this array is going to be 5. Later, if you want, you can change your size. That is the advantage of this dynamic memory allocation. Clear? Okay, so now let's discuss CLOC. What is CLOC? What is a CLOC function? Give me the prototype of CLOC. And what's the difference for malloc and CLOC? Where to use CLOC? Super. CLOC is also only, it's going to be one of the allocation function. Okay. Guys, give me the prototype of CLOC. And if you don't know the answer, you can post dot. Super, excellent. CLOC is going to be number of blocks and size of each block. Super, excellent. So what's the difference between MLOC and CLOC? I think you people are doing Googling. See, for memory allocation, we'll use MLOC. But what about CLOC? CLOC is also we are going to use for a memory allocation alone. CLOC allocates continuous block of memory. Super. See, I already told you that, excuse me, static and dynamic. It can be either static or dynamic. Memory is always going to be continuous. Only then we can call this as an array. That is the property of an array. CLOC allocates when requested the memory. See, this is not an university exam. Okay, I made it very clear. This is an interview. You should give a proper answer for a question. Okay, so MAlloc, CAlloc, both are going to do allocation. When you comes to an array name itself, the one of the property of an array is going to be a continuous memory. It can be either static or dynamic, right? Okay, so if you want, let me display the address for a dynamic first. Let me clear that doubt. Listen. Now, let me command all these things. After done a memory allocation, what I'm going to do now is I'm going to print the address of a block less than n index plus plus. So how will you take an address is going to be %d array plus index. Okay, let me run it. 5. Look at this. Look at the address. Address are in a continuous order because this is an array. Okay, it can be either static or dynamic. Okay, that is not our point. This is an array. If this is an array, address is going to be continuous. Only then we can call this as an array. Right? Okay. I hope now it's clear for you. Yes. So now, okay, I hope now it's clear for you. Now tell me, what is CLOC? What's the difference between MLOC and CLOC? The prototype of CLOC is correct. CLOC of number of blocks of comma size of each block. This one is correct. But what is CLOC? Still I didn't get the answer. Okay, C stands for what? C allocation. MAlloc means M stands for a memory allocation. C stands for what? CLOC requesting memory at the runtime. Guys, both MLOC and CLOC, it's going to request memory at the runtime. C stands for what? C. Actually, I should appreciate you. You can make mistakes here. Okay, so you can make mistake here. If you made mistake here, you can learn something. You should not do the same mistake at your interview. If you did, definitely that is going to be the last for you. Okay, super. CLOC requesting memory at runtime means both MLOC and CLOC is going to be requesting memory at the runtime only. Next, CLOC stands for what? C stands for what? First. If you get that one, CLOC of memory at the runtime. Same answer. Next. Guys, it's not a contiguous one. Now only I show you the demo. What do you mean by single block of storage, multiple block of storage? I didn't get that. Manoj Kumar, single block of storage means what? Okay, let me explain it. Don't waste time, okay? So first, CLOC, first parameter is going to be number of elements. Next one is going to be size of each element. Right? Okay, return type is going to be void star, which is similar to the MLOC. Return type and all those things which is similar to a CLOC. Right? So C stands for clear allocation. C stands for what? Clear allocation. What do you mean by clear allocation? While doing a memory allocation, for us this is a bit. Generally, we are going to request number of bytes for a memory, right? For us, this is a bytes. For a system, this is going to be a bits. 1 bit is equal to what? 1 byte is equal to 8 bits. 1 byte is equal to 8 bits, right? Okay, so listen, while doing a memory allocation, system is going to clear all the bits. Clearing means cleaning. Clear all the bits so that you will get the 0. Listen, here I did a memory allocation. Okay, I didn't do any initial setup for this one. So what I'm going to do now is I'm going to display the array elements. So if you want to take the array elements, means array of index, right? So let me run it. So listen, 5. Look at this. What is this? Is this an address? No. Address means that should be a continuous one. First thing. Address means that should be a continuous one. So now, what is this? What else is this? This is the garbage value. This is going to be a garbage value. Here we have declared an array, but we didn't do any initial setup for that one. Means the initial value of this array is going to be a garbage value, right? Okay. Now I'm going to do a calloc. Calloc means first parameter is going to be number of elements. Then size of each one. This is going to be an integer array. So I'm going to write an int. Here also we bought a memory. Sorry, we are requested a memory for an integer. So that here I'm going to convert this as an integer star, and then you can store it in array. That's it. This is the only difference we are going to do. Right? Okay. Now let me print the address. Let me print the address first. Look at this. The address are in what? Continuous order. But there is a difference in addressing system also. Look at this address. This address is having less number of digits than the previous one. Right? There is a difference in that stack and heap. While allocating a memory, some memories are from the stack and some memories from a heap. So we'll have stack and heap concept. That is the reason there is a change in our address. But other than that, look at this difference. This is the contiguous memory allocation because this is an array. It can be either static or a dynamic. Okay, you can use either malloc or calloc. Address is going to be contiguous. Right? Okay, now if you print that array elements, if you print it, look at this. You got what? 0. Okay. We didn't do any initial setup. But the initial value of our array is what? We are having a 0. Because we have used a calloc. Calloc means clear allocation. Malloc stands for memory allocation. So we can use both malloc or calloc. But the difference is if you are using a malloc, the initial value is going to be a garbage value. If you are using a calloc, the initial value of your memory is going to be 0. Okay, if you want to set your initial element of an array with 0 means better is to use calloc than malloc. This is the only difference of malloc and calloc. Right? Okay. Guys, is it clear for you? Super. Initialize them into C. You should not use the term called initialize. Set it. Okay. So while doing a memory allocation, system is going to clear all the bits. So that I just said clear allocation. Clear means clearing the bits. They didn't do a initialization. If they start doing an initialization means that takes some time to do it. Clear? I hope it's clear for you. Guys, do you have any doubt in malloc and calloc? Guys, any doubts? Feel free to ask doubts. What is the UD? UD means what? Manoj Kumar? UD means what? I didn't get you. What about others? What is the use of, okay, what's the use of setting 0? See, listen, we can use array as a counter, but sometime we can use our array for a purpose of a counting process. So at that time, we know that For a counter means that should be initially should initialize with 0. Generally, we will initialize our counter value with 0. So at that case, we can use a CLOC instead of using a MLOC. This is one of the use. Okay. You want me to explain once again? Okay. See, first thing, you have to be clear in a syntax. That's it. Let me show you the syntax of both MLOC and CLOC. Because this syntax plays a, this prototype plays a major role. If you are strong in this means, next task is to just use this one to get that, right? Yes. So just take a look of it for only the one parameter, which is going to be a number of bytes. Okay. In case if you want to allocate memory for a 5 integer means, at that case here you can specify just 20 is alone. But in case it's a CLOC, you should specify your parameter like this: number of elements and size of each element. Okay, hold on. Okay. So int array of 5. This is normal declaration. Here we did static. Now I'm going to do a dynamic version for this one. Okay. malloc of, for storing a 5 integer, how many bytes we need? 5 into 4. You can write 4 or else size of int. Okay. Here we have requested a memory for an integer means while doing a typecast, we should convert this into an int star. And then you should store it in somewhere. I'm going to store it in array. Hereafter, you should not declare your array like this. You have to declare like this. Right? So this array is a pointer, but this is pointing the array. This is a pointer. This array points the continuous block of memory. So that we can call this as an array. Right? Okay. Now, this is the version for using malloc, and that CLOC means, see, you can do either malloc or CLOC. In CLOC, first parameter is going to be number of elements. Second one is going to be size of each. That is going to be int. Typecasting is going to be same for both. Typecasting and declaration, it can be same for both. Okay. Both are continuous memory allocation. Only the difference is, if you bought a memory for storing a 5 integer means you have 5 blocks or that each block having the size of 4 bytes because this is an integer, right? So the initial value of that array is going to be either a garbage value or a 0. That is based on this malloc or CLOC, what we have used for that memory allocation. Right. So if you have used malloc means the initial value is going to be a garbage value. If you have used CLOC means initial value is going to be 0. That is how it works. Clear? See, they didn't do an initial setup after allocation. You should not say like that. While doing a memory allocation, they are going to off all the bits. Okay, they are going to off all the bits. So that only at last we got 0 as the initial value. Clear? Syed, is it clear for you? Okay. The advantage of using this malloc and CLOC is going to be, in future, if you want, you can do a reallocation. How will you do a reallocation? Realloc is a function. For that function, what you have to do is you can pass the existing memory. Existing memory address. Memory means address, right? So existing address. And here you need to specify the number of bytes we need for existing memory, existing bytes plus additional bytes. This number of bytes is the meaning of what you have to do is existing memory size plus new memory size. That's it. And this also will return the void stub. This also will return the void stub. So here we need to pass a two parameter. First one is going to be the existing address. Second one is going to be the number of bytes. Okay, so we'll do for this one. Okay, how will you do a realloc for this one? Look at this. Here you can use either malloc or cloc. Okay, so after memory allocation, you have stored that address in the variable called array. Because so far we have allocated some memory, that address we have stored in the variable called array. Right. So if you want, you can do a realloc. For that realloc function, you should pass the existing address. Existing address we have stored in the variable called array. That I'm going to pass it for this one. Right. So for existing size means existing memory we bought for storing a 5 integer. Existing memory can hold the 5 integer. So the size of existing memory is going to be what? 20 bytes. Am I right? So how will you get that? 5 into 4. 5 into 4, 4 is nothing but size of int. Plus this is our existing. Additionally, I would like to store 20 elements to this array. Initially, we bought this array for storing a 5 integer. Now I would like to add 20 elements to this array. Means here you should buy additional memory for storing this 20 bytes. That's it. Okay, so listen, look at the both statement. This multiplication of size of int is going to be a common. Sorry, this is going to be common. So what you can do is realloc of existing memory 5 plus 20 into size of int. That's it. So finally, we can convert this into one in star, and then you can store it in the same address. Hereafter, we don't want this existing address, so that I'm going to replace it with a new address. So for this realloc, you can pass a existing address, okay, and then existing size plus new size into size of integer. So now we'll get some new memory that I have stored it in the variable called array. This is how we can, this is the use of dynamic memory allocation. This is where we need dynamic memory allocation. If you want to change the size of an array in future means you're supposed to do a dynamic memory allocation. Clear? Okay. Guys, is this clear? Yes. If you want to reduce, you can reduce it. Yes, but Badmini, you can do. If you want, you can increase, or if you want to reduce, you can reduce it. Guys, any more doubts? Okay, so we have completed dynamic memory allocation pointers. In pointers, I have explained about this void. What is this null pointer? Null pointer means while declaring, if we have initialized that pointer with a null means we can call this as a null pointer, right? And invalid pointer means if you didn't do any initial setup for your pointer variable, at that time that pointer is pointing some invalid address, so that we can call this as a invalid pointer. Okay, and pointer to a pointer is nothing but you can store address of another pointer is also you can do. Generally pointer points anything. Okay, you can use this pointer to point the data or pointer to points a address. So that is the pointer to pointer. And we have discussed this pointer arithmetic. The balance is going to be enumeration, structure, and union. Okay, guys, do you have any other doubts? Okay, that 2D array I'll explain in next session. Okay, because we have half an hour, we can't complete in half an hour, so I'll explain in next session. Definitely I will explain 2D array to pass array to function in runtime. See, for that we'll have a 3 different types are there, so I'll explain it. Okay, super guys, any other doubts? Do you have any other doubts? Lakshmi, you're asking about to clear the values or memory. Make it clear, I will explain. You want to clear the values or you want to clear the address? Values. Okay, super. See, if you want to clear the values means what you have to do is you have to close the entire array and you can set it with either -1 or 0, that is based on your need. Listen. So after that, finally, if you want to reinitialize or clear the values means for index starts from 0, index plus array of index is equal to 0. This is how we can clear. If you want to reset all your values with 0 or -1, that is based on our need, right? But if you want to clear the entire array values means this is how we have to clear. Okay, and while doing a dynamic memory allocation, this memory is going to be a permanent one. Once you've done all your process, what you have to do is you have to return your memory. So how will you return your memory? First, initially we have sent a request to a compiler. Finally, once we done all our process, so what we have to do is free of existing address. So here what you have to give is free of existing address. So you should send the already allocated address to this function. What this function does is this memory is no longer to be you. This is no longer to be you. Hereafter you can't use this one. Okay, so once you have completed all your process, in case if you did any dynamic memory allocation in your program means at last, if you have done all your process means finally return that memory to your compiler. How will you return back is we can have this free function for that process. Clear? Okay. Okay guys, any other doubts? Yes. Okay, guys, any other doubts? Okay, what do you mean by enumeration? Guys, what do you mean by enumeration? Super. Enumeration, structure, and union, all these are comes under a user-defined data type. Indexing elements start from 0. Okay. See, this is not a type of an array. So better is not to use the term called indexing. Okay. See, enumeration generally will use this for assigning name for a integer constant. Okay, assigning name for a integer constant. Generally will frequently use a term called true and false, right? Okay, let me explain it. User generally will use true false in our statement, right? So true means it's always indicate 1. Okay, false means 0. So instead of using a 1 and 0, if you are using a true and false means that sounds good, right? So this is what my need. So I would like to use a true, but wherever I want to use a 1 means instead of using a 1, I'm going to place a true, but that should get replaced with a 1. That is what my need, right? So for that, what we can do is, listen, hash include stdio.h int main. So how will you declare a enumeration? How will you declare an enumeration? For that, you can use the keyword called enum. You can use the keyword called enum. So I'm going to write, I'm going to give a name for that for my enumeration. It's going to be a state. It's going to be a state, right? So now here I'm going to mention it, right? So the first one I'm going to write it as false. As you said, this indexing starts from 0. That is not an indexing. This value should start initialized from 0. Okay, so they have mapped, 0 is mapped to this false, 1 is mapped to this true. So after that, listen, if you want, you can create one variable, right? So listen, state is my enum name. State is my enum name, S1. Right, so I have declared one variable for my enumeration. Name of this enumeration is going to be state. I have declared one variable S1 in the type of a state. Right, so after that, what I'm going to do now is, okay, so okay, so false. If you have assigned false to this S1, okay, so you can assign this one like this. So what will you get? What will you get the result? This false is mapped with what? This false is mapped with 0. Okay, likewise true is mapped with 1. Okay, so listen. So that what we can do is, now we can see these are all nothing but the name of an integer constant. Here the constant is going to be 1 and 0. We have given a name, right? So we have given a name. Okay, so S1. So here I have declared one variable S1 in the type of state. After that, I have assigned this false into a S1. So after that, what you can do is you can print this S1. What you can do is you can print this S1. I'm going to print this as an integer, as I told that this is the name for an integer constant, so that you can directly use a percentage. Listen, what will you get first? Let me command this and then close it or run it. Okay, here, which one you should place it at outside? Right, state. If I did any spelling mistake here, okay. I made one thing here. While declaring also, you need to specify enum. The reason is, I told you the reason. It can be either union or a structure or an enum. Okay, all these three are comes under what? All these three are comes under user defined data type. So before write like this, so what we have to do is, here you should write the enum. If you don't want to write like this, what you can do is, you can do a type. Okay, so type enum state. Instead of write like this, I'm going to write state. Okay, see, this is how you're supposed to write. But what I have done is, I have given a new name for my enum state with the help of this title. Generally, we are doing this for a structure. If you are doing this for a structure, means we can do the same thing for a enum also, because enum, structure and union all are same, right? So now, first let me run it with enum keyword. Right, what you got? You got 0 as a result. The same thing, instead of this one, what you can do is, you can use a state. See, for some difference only here, use this with the enum keyword, means what you can do is, you can give a new name for that one. So you can give a new name for an existing one with the help of that type def. Clear? Okay, so now we have finished. In case if you have assigned true here, you'll get what? You'll get 1. If you have assigned 2, you'll get 1. Right? Okay, so this is one option. So initially, all your values or start get initialized with what? 0. But what you can do is, if you want, you can manually set your value. So I would like to set for 5 for my false. So the name of 5 is going to be a false. So now tell me, what will be the output for this one? Here I didn't mention anything. See, in case if you want, you can mention 10. So if you have access to true, this place should get replaced with 10. Likewise, if you have used a false, means you will get 5. But if I didn't give any initial setup for this one, means this will automatically will get assigned with previous value plus 1. So here, look at the previous value. The previous value is going to be 5, means automatically this true is get assigned with 5 plus 1. So now if you are using a true, means you will get 6. Now you'll get 6, right? And then likewise, listen, let me show you the demo. What I'm going to do now is, I'm going to D1, D2, D3, D4, D5. Right, so generally D1, D2, D3, D4, D5, if you have used the D1, means what will you get? You will get 0. As we know that if we didn't give any initial if we didn't do any assignment, the default values start from 0. Right, so if you want, you can set this as 1. If you have set it as 1 while accessing a D1, you will get 1. Likewise, if you have assigned D5, what will you get? Now tell me, what will you get? What will be the output for this code? And tell me, what will be the output for this one? Guys, what will be the output for this one? 5. Okay, super. So the initial value we have set it as 1 means automatically this will end up with 5. Super, excellent. Right. So now tell me what will be the output for the previous code. Answer is going to be 5. So now tell me what will be the output for this one. D5. What will be the output for D5? What will be the output for D5? 12. Super. The output, super, excellent. 12, because D3 I have set it as 10 means D4 is going to be 11, D5 is going to be 12. This is how we get 12. Right? Okay. So D2 is going to be what? D2 we didn't give, but D1 got assigned as 1. So that you will get 2 as a result. Right? So if we didn't do any initial setup here, if we didn't do any initial setup means D1 is assigned with 0, D2 is going to be what? 1. So this is how this enumeration works. We can use this, see, instead of using an integer value, what we can do is we can use what? We can use enumeration. And one more thing, listen, can we assign a same value for both D3 and D4? Okay, can we assign the same value for D3 and D4? Guys, can we assign it? Is this possible? Is this possible of having a two name points the same integer constant? No. Okay, so let me run it. Let's see the output. First, I'll print D3. That is no error. D3 will give you what? 10. In case if you are using a D4, that is also gives you 10. So you can, that means this is possible. You can assign different name for the same constant value. Okay, D3 and D4 both are going to gives you the same value, which is 10. This is possible. Yes. Okay, guys, is it clear? Do you have any doubt in this enumeration? Clear? Okay, so the next one is going to be a structure. Okay, next one is structure. So what do you mean by structure? Structure is also comes under a user defined data type, but structure is going to be a single name. See, under the single name we can store the multiple values. Okay, for example, a student information is an entity. It's an entity means student information is having a student name, and then roll number, date of birth, and your CGPA and your address, parent information, like that will have a lot of information out there. Your height, weight, and all those things. Okay, so this is going to be a collection of data, but we are going to refer in the single term called student information. Student information is the single term. We can use this one, right? So this is nothing but a structure. So when it comes to a structure, what you can do is you'll have a two operators. See, you have an initialization and how to access a member. Okay, and all those things are there. Let me explain it one by one. Like enumeration, while declaring a structure, you should start the keyword with struct. Okay, let's take a simple thing. Let's take point. This is easy, right? So the name of this structure is going to be point. Point means definitely you'll have a 2 point that is going to be X and Y. Okay, so listen. Now we have done the declaration part of this structure, right? Okay, and then next, while creating a variable, so this which is similar to an enumeration, while creating a variable, the name of this structure is going to be what? Point. point P1. I'm going to declare P1. But before that, what you have to do is you have to mention the keyword struct. Without this keyword, system can't analyze whether it is a structure or an enumeration. So that only in case if it is an enumeration, you should mention it as an enumeration. In case if it is a structure, you should mention it as structure. In case if it is an union, means you have to mention it as union. Right? Okay. I don't want to use this struct keyword. Means what you can do is you can use a type def. Type def struct point. Instead of this one, I am going to use a point. Right? So hereafter, I am going to use a point P1. Right? Okay. So now we have done a variable creation, and after that, I am going to initialize it. Here, I am going to initialize it. 10, 5. Okay, so 10, 5 means this 10 is going to assign it for the first variable which we have declared inside this structure. Likewise, if you have passed 5 to the structure, means this 5 will get assigned to a y. And after that, after done the initial setup, I would like to print my structure element. So for accessing a structure element, we'll have a two option. You can use a dot operator and arrow operator. Okay, so when to use a dot operator? If you have a structure variable, if you are having a structure variable, means you have to use a dot operator. Look at this. P1 is just a variable of this point. See, why did we call this as a user-defined data type? This P1 is a variable. We have declared this in the type of a point, like int num. Int num means num is a variable, int is an data type. Likewise, this point is also a data type, but this is a user-defined data type. Right? Okay. So, if you are having a structure variable, means while accessing, what you can do is you can use a dot P1 dot x, P1 dot y. Okay, so why did I use P1? Because this is the x which is present inside the P1. Likewise, listen, in case if you want, you can declare P2 also. So that you should mention whether this x belongs to whom, whether it's P1 or P2. Right, so now let me run it. Got it? So now this 10 and 5 we got assigned for a x and y. And then if you have printed for a P2, we didn't do any initial setup for a P2, so this will give you some garbage value. Right? And you might have one question. While doing an assignment, while doing an initial setup, always it should be an order. No. If you want, you can change your order. Listen, initially here I have 10. I have given a 10. This 10 is going to assign to x. Likewise, here I have given a 5. This 5 is going to assign for y. On other hand, if you want to change the order, means dot y is equal to 10, comma, dot x is equal to 5. You can assign like this also. If you want to change the order while doing an initial setup, you can change like this. So, but while printing what you got, if you print x, x is assigned with y. If you print y, y is assigned with 10. So, while printing, this is what you got. This is one option. Right? And one more question. Can I do an initial setup here? Can I do an initial setup inside a structure? No. If you did this, this will give you an error. Because this structure is a template, it's a model, it's a stencil, you can call it whatever it is. Right? So, this is a stencil. That means this doesn't get allocate any memory. So, you can't do any initial setup for this. Right? So, we have completed up to this dot operator. In next session, we'll start from arrow. Right? So, these are the basic things you should know while solving a data structure problems. Clear? Okay. Guys, do you have any doubt up to this? Guys, any doubt? Yes. Okay. Thank you. So shall we wind up the session? Okay, guys. Thank you all. We'll see you in the next session. Okay. Thank you.